Okay. Good morning, at least it is to me, late morning. So today we're going to talk about 7.4, which is arc length. Okay, and actually arc length, I don't sleep on arc length. I used to be like, oh, it's just arc length. But arc length is actually one of the sort of pillars of modern science. I know it seems weird, and maybe it feels like I say that for everything. But the concept of arc length is one of the key pieces of general relativity. And subsequently mechanics. So what happened was, Einstein developed relativity in 1915, which seems like forever ago. But with the ideas that he created, excuse me, all the other stuff, like all the other stuff that had been developed, mechanics and whatnot, sort of went through a revamping. And they were looked at with this new vision that Einstein had given us. And this idea of arc length was one of the key pieces. Okay, so let's start by the definition. So the arc length of a curve is S equals the integral from A to B square root of 1 plus f prime of x squared dx. Okay, so where does this come from? So if we draw a nice little picture, okay, we go from A to B, we have a curve. Okay, we start splitting this curve up into pieces. Okay. Let's do one more. And then here, let's say we're going to take the arc length here is given by sort of the Pythagorean theorem. So let's take this to be dx. This is dy. So really what we have is we have this thing called ds, which is the differential arc length. You don't really need to know that. And that's going to be dx squared plus dy squared. Okay? So now what we're going to do is we're going to pull out the dx squared. So that means we're going to get the square root of 1 plus dy over dx squared. Let me make that square root a little bigger. And then dx. Okay? And this is what we're integrating. Okay? All right, so that's where it comes from. And again, it's one of these sort of critical ideas. Don't sleep on it. Okay? All right, so let's go ahead and find some. So we're going to start with an easy one. Let's take y equals 3 plus 2x, negative 1 less than or equal to x, less than or equal to 2. Okay, and this one actually, we don't even need the formula. Okay, we're going to just recognize that, hey, this is just a line. Okay, it's a line connecting negative 1. If x is negative 1, y is 1. Okay, if x is 2, y is what? 3 plus 4 is 7. Okay. There it goes. Okay. So now, in this case, it's pretty easy. Our dx, or the delta x, we'll call it, is 3. Delta y is 6. So our s, of course, by the Pythagorean theorem, is the square root of 3 squared plus 6 squared, square root of 9 plus 36 equals the square root of 45. Okay, now I did that, but I also want to show you how the integral shapes up. Okay, so the integral is going to be, so let me write by Pythagorean theorem. Okay, but we can still use the same formula if you really want to. The integral from -1 to 2, okay, the square root of 1 plus dy dx in this case is 2. Okay, so now that's going to be, let's calculate that. Put that here. So that's going to be what? We're going to integrate 5, root 5 from -1 to 3. Sorry, -1 to 2. That's root 5 times 3. Well, what happens if we take root 5 and put it in, or I'm sorry, the 3 and put it inside the square root? It's going to be 9. Or, identically, we could say this is square root of 9 times 5, 3 root 5. Okay? Same answer. All right. I'll see y'all in the next video.